So now we're going to talk about the major ocean currents and why are we learning about ocean currents when we're talking about atmosphere and climate? Well, what's happening in the oceans has a major influence over what's happening on land nearby. And so we are going to now look at ocean currents. So the ocean absorbs heat from the sun rays. As you well know, that water heats up, but it has a very high heat capacity. So it warms up pretty slowly and cools down pretty slowly as well. That is important to note as we move forward in this unit, in the course in general. So as the sun's rays are hitting the ocean, this is very direct in the equatorial regions, and therefore the water in the equatorial regions have very warm water. When this happens, water expands. There is a phenomenon called thermal expansion, and thermal expansion happens because as water warms up, it does actually physically expand and increase its volume, and up to a certain point where it actually turns into a gas. And so what this does in the ocean currents, while we're talking about it, is it actually physically raises the surface of the water. And once this happens, the water runs just by pure gravity away from the equator. The prevailing winds will push the water one way or the other, so depending on the hemisphere you're in, either clockwise or counterclockwise. And so here's a picture of all the major ocean currents that on Earth. You don't really need to know the specifics of each one, but what you should remember is the Gulf Stream here. So the Gulf Stream stems from this equatorial region, and it comes up past the east coast of the United States and over into Europe. And so this is important for us because this is what affects us the most. On the other end of the country, you also have this Pacific Gyre. This Pacific Gyre is actually talked about a lot lately because that's the location of the Great Pacific Garbage Patch. So because of the spinning of the water, or the circulation of the water, it actually forms a little pocket in the middle where a lot of plastic pollution gets caught up, and so that's what they call the Great Pacific Garbage Patch. So not only on the surface, but we also have currents happening underwater. And so upwelling is something that happens in the ocean where the deeper water, like deep water, that's very nutrient rich, actually come up and rise to replace the water that has moved away. And so if we go back to our picture, right, you have this water here moving this water is moving away from the west coast, and this water, the deep water on the west coast, the deep water on the west coast is actually coming up to the surface, and that's why it is so cold. So not only is it cold, it's also super nutrient rich, and that's really important for phytoplankton, who are the primary producers in the ocean, who are the basis for the entire food web in the ocean. So we have these cooler temperatures on west coasts of continents and warmer temperatures on the east coast of continents. So the other thing that we're going to be concerned with in the deep ocean is this thermohaline circulation. And so when water gets up into the Arctic, it actually freezes. When water freezes, it leaves salt behind. So the salt concentration in the Arctic, the liquid Arctic, is actually higher in salt concentration. And so this really cold, salty water is a lot more dense, and then it sinks down. And so as it moves down towards the equator, it ends up and melts. Or not melts, sorry, right? Scratch that. Forgive me. As the water moves down to the equator, it warms up and ultimately rises again. So you have that convection cell that we've been talking about over and over and over and over again. Okay, so El Nino, or Southern Oscillation, or ENSO we call it, It is a phenomenon that doesn't happen every year, and so I'm going to explain it. This is just a funny video. I'm not going to play it in my video, but if I played it for you in class, you know it's funny. So El Nino is an actual change in the direction of the tropical winds. And so those northeast trades and the southeast trades actually either stop or reverse blowing. And so therefore it's not pushing the water over to the west. Instead, that water is sitting there, and you have warm water sitting up against the west coast of South America, North and South America, and the upwelling is not able to happen, and so that nutrient-rich water doesn't come up, and so the phytoplankton doesn't get fed, and we have a major drop in fish stock, and then up and up and up the food chain. And so it does alter Earth's climate a lot. So you can see here is a picture of it. So this is what happens normally. We have these trade winds blowing west, and then on the east coast here you have an upwelling, so you have nice cold water coming up here. So where there's warm water, we have a lot of rain, because warmer air has the ability to hold more moisture. And here you have cool, dry temperatures. And when those trade winds stop, what happens is that upwelling can't happen. The warm water stays over here, and you end up with wet weather over on this coast and dry weather on this coast. So it's kind of an opposite of what happens normally. And this is just reiterating what I said before. And finally, La Nina is the exact opposite of El Nino, where those trade winds are actually increasing, and so you end up with a lot cooler surface waters than you would have normally. And so there is a little video that you can watch in the links that I posted in our shared drive and also in the materials on Classroom. So go ahead and watch this El Nino video for more clarification.